In your opinion, which one is close to the school? Yeah, because if you check graph over here, both the students are starting from what? Origin, and that is the school, right? So the position time graph for the children A and B returning from their school to their home. Okay. P and Q respectively are shown in the figure 2.9. Choose the correct entries. Now A or B lives closer to the school than B or A. So who is living closer to the school? So you can see that you have a P on the graph and you have a Q on the graph. So who is near to the school? This is the house of A and this is the house of B. So first question, Isabella, who is more nearer? Sida, you understood? From school, A's house is this. So this is the distance. B's house is this, and that is the distance. Who is nearby? So in the question, A is nearby. So answer is A's house is what nearby than B's house. Sida, you understood? Now you read the second question. So when we read the second question, A and B start from the school earlier than. Who started earlier? Sida. Yeah. So when time t is equal to 0, A started. So second question, A started earlier. So A started earlier. Now first question was what? A's house is what? A's houses nearby. A's houses nearby. A's houses nearby. Now third question. Yeah. Tell me, Gaurav. Third question. Yeah, who walks over here, A or B? Yeah. Isabella, who walks faster over here, A or B? So how you can check it? So to check that thing, what you need to do that you have to check the slope over here, right? Slope. So you check the slope over there. That will be giving you what? Speed, right? Now let's say this is the slope of A, that is theta A, and this is slope of B, theta B. Which is greater, theta A or theta B? Theta B is greater. So since theta B is greater than theta A, speed on that speed of B is greater than that is the point to be noted. Now fourth question. What is the fourth question? Yeah, fourth question is asking you A and B reaches home at the same time or different time. Yeah, tell me, Sudha, what is your opinion? Are they reaching their home at the same time or different time? Okay, yeah, so they are meeting at a position that is actually what? They are actually meeting at a position, they are meeting before both of them reaching home. After that, the graph is not crossing anywhere. So which means what? They may not be reaching the house or same or different. That in that scenario, that you have to calculate the case. So what you need to do over here is that you need to draw a line. So you take your graph, Siddha and Elizabeth, you take your graph and draw a line parallel to what? Parallel to P. Make sure that what that line is going and hitting on the graph of A. Similarly, you draw a line parallel to Q and make sure that what that line is going and hitting on what? Hitting on the graph of B. Then what you need to do? Equivalent at the timer you have to drop down. So which means this is the time where B is reaching house and this is the time where A is reaching house. So we mark it. both of them are actually reaching the home at same time. So our fourth question answer is same time. So how you can check into that thing? This is Q is the house of B. Now you draw a line, and that line is touching at what? Touching the graph. That point you have to drop a line to the time curve. Okay, that will be the time B is reaching the house. Similarly, you drop a line from P to the graph of A and drop a line. That line touching on the graph is what? Time taken by P. Okay, so that you understood that point? Understood? Hello? So this is what is the case over there, you should remember, right? Okay. Now, next question over there. E, that is A or B overtakes B or A on the road once or twice. Yeah. Isabella, tell me your opinion. Yeah. Yeah. So B is overtaking the road A once. So at what point they are overtaking? Our intersecting point. Okay. About fifth question. B overtake A. B overtake A once. This is what is the answer to that question. Okay. Once again, I'll explain you the graph. So here you have a graph. In the graph, what do you have to remember? So this is the position time graph. First question, they were asking you, whose house is nearby? So in the question, it is given that what P is the house of A and Q is the house of B. So from the school, P is nearby. That's why A's house is nearby. That is answer to the first question. Second question, from the school, both of them started. Then question is asking you who started early. When time t is equal to 0, A started from the school, but B is actually starting at a later time. From the school, A started earlier. That is the second question's answer. Third question, who is moving faster? The speed. How you can find it out? You find out the slope. When you check the slope over there, slope of B is more than slope of A, and even it is overtaking. B is overtaking. It started late and overtaking means it has to be what? Going with a larger speed. Our speed of B is greater than A. Now last, this is little bit confusing one. Are they reaching the home at the same time? So I drop a line from Q to the graph of B. Right? Now it is touching at a point. Point I am dropping a line to the time curve. Okay. Similarly, I drop a line from P to the graph of A. Now where it is hitting on the graph of A, I am dropping a line to the time axis. So from there, I will be getting that what? Both are actually reaching the house at the same time. So that is the only little bit confusing thing. Everything else is easy only. Now, the last option, A or B overtaking in the norm. So answer is what? B is overtaking A one time. Okay? Right. Now, write another question. Vedika. Write another question. A woman starts from her home at 9 a.m. A woman starts from her home at 9 a.m. A woman starts from her home at 9 a.m. Walk with a speed 5 km per hour. Walk with a speed 5 km per hour on a straight road. On a straight road up to her office on a straight road up to her office 2.5 kilometer away. Up to her office 2.5 kilometer away. Then she stayed at the office up to 5 p.m. Then stayed at the office up to 5 p.m. Stayed at the office up to 5 p.m. and returns home by auto. Returns home by auto with a speed of 25 km per hour. Choose suitable scale and plot a xt graph of her motion. Textbook question ആണ്. Question number 2.3 കേട്ടോ. Check ചെയ്തേ and try to draw it. വരയ്ക്കാൻ നോക്കിക്കേ. That return home by an auto with a speed of 25 km per hour. Return that. Yeah. Choose suitable scale and plot a xt graph, position time graph. Choose suitable scale and plot xt graph. കിട്ടിയാ Rebecca? Isabella കിട്ടിയോ Isabella? Okay. Karo കിട്ടിയാ? Yeah. Hello. So she started from her house at what time? So 9 a.m. So you keep the 9 a.m. as what? Origin. So you are drawing the graph from what? 9 a.m. to the evening. Now, this is the time and this is the position. So if you check it over there, yeah, what we can see over here is that so what we can see over here is that yeah. So start from home 9 a.m. walks with a speed of 5 km per hour. So what is the speed? So the speed she is having is what? Speed is equal to 5 km per hour and office at what? Straight road up to her office 2.5 kilometer away. But the distance traveled, distance. So the distance to be traveled is 2.5 kilometer. Now already the time taken. So let it be t1. So the time taken will be what? Speed is equal to distance by time. So time is equal to what? Speed is equal to distance by time. Time is equal to distance divided by speed. So distance divided by speed, you will be getting this is what? 2.5 divided by 5, that will be equal to what? 0.5 hour. So the time taken over here is what? Half hour. So which means precisely between 9 a.m. and 9:10 a.m. So almost she will be reaching her office at what? She will be reaching her office at precisely that office. So this is the office. So she will be reaching the office at what? 9:30. So the time over there at 9:30 she reached our office. Office at 9:30. So this is 9:30. Now from 9:30 till what time? So till evening 5 p.m. So let's say from 9:30 she is at office till what? Till evening 5 p.m. So let it be evening 5 p.m. Then this is the morning journey. Any afternoon, evening journey. Here she is coming back in an auto. Speed is actually what? 25 kilometer per hour. Distance is same. So distance again 2.5 kilometer. So the time taken for the return journey T2 is equal to what? Again same distance traveled divided by speed in the back case. So that is equal to distance traveled is 2.5 kilometer divided by 25 kilometer per hour. So that will be equal to what? 0.1 hour. 0.1 hour it will be reaching. Is that okay? Got it? So which means immediately 0.1 hour immediately she will be reaching. So this will be the after 5.1 5.1 hour 5.1 hour she will be reaching home. Graph here it will be what? Here it will be going from what? Office. House to office, this will be the case. Now till evening 5 o'clock, that person is at rest. Then return journey, immediately going back. So this will be the return journey over there. Okay, but the graph will be looking like this. Understood? Shida, understood? Yeah. Blurry. Is that okay? okay now? Problem with settings. Just a minute. Let me check that. Is that okay now? Shudha, is that okay? Yeah. Now, we'll do one more question and after that we'll go to the questions. Another question. Write down. Because most of these questions are featured in the textbook, but it is nowhere related to the concept what we are writing over here. A car is moving along a straight highway with a speed. A car is moving along a straight highway with a speed 2.4. You do as a homework. 2.4. 2.4 do as a homework. That's an easy one. A car moving along a straight highway with a speed of 126 kilometer per hour. 126 kilometer per hour is brought to a stop with a distance of 200 meter. Is brought to a stop at a distance. It brought to a stop at a distance 200 meters. Is brought to a stop at a distance 200 meters. What is the retardation of the car? And how long does it take the car to stop? What is the retardation of the car and how long does the car take for the car to stop? 2.5. So this is 2.3, now 2.5. Take the 2.4 as what? Homework. Homework. Okay. Isabella, okay la? Yeah. Siddha? Okay. So you need to visualize. We have three equations. B is equal to U plus AT. S is equal to UT plus half AT square. B square is equal to U square plus KS. Three equation. Now, any equation. You need three known and one unknown thing. At least three. Okay. Now, in this question, you know something, that is what a car is going with a speed and the car is going to stop. So, what are two things you can take it from here? So, car is going with a speed is the initial speed. Okay. Now, car is going to stop means final speed is 0. Then, what else is given? Distance. So, our distance is so initial velocity U, final velocity V, and the distance S is given. So there is no clue about time. If there is no clue about distance, your formula is d is equal to u plus 80. That's our priority formula. If there is no clue about final velocity, your formula is S is equal to ut plus half at square. If your formula, that question is having no clue about the time taken, your formula is what? V square is equal to u square plus 2as. But in this case, there is no clue about what? Time taken. So you can apply V square is equal to u square plus 2as. Okay? Understood? So apply that formula and find it out, and make sure that what? Speed is not given in meter per second, convert it. Okay? Okay now? Yeah. So given final initial velocity is given 126 kilometer per hour. So that will be equal to 126 into 5 divided by 18. So 18 yeah, 7 times. So it will be going 7 times. So we'll be getting this as what? 35 meter per second. Now final velocity is 0 meter per second, and the distance. How much is the distance traveled? Distance? So it is 200 meters. So 200 meters. So I told you what formula to be applied. V square is equal to u square plus 2as, or 0 is equal to 35 square plus 2as, or you'll be getting that what? 2as is equal to minus 35 square, or you want a to be find out. A is equal to what? Minus 35 square can be written as 35 into 35 divided by 2 into S over there is what? 200. Okay. Now you can cut the 235, 7 times 35, 20 liters 4, so 40 times. Again you can cut it 7 times, 40 it will be 8 times. So you'll be getting this as what? Minus 49 divided by 16. So 49 divided by 16 is 48 by 16, 300. So this will be 3 times 48, then 1. It is not going, so 0, 100, it will be 6 times. So we will be getting this as what? 3.06 meter per second square, and there is a negative. That negative represent what? Negative represent, this is not acceleration, this is what? This is deceleration is happening over there. Our speed is decreasing, so deceleration is happening over there. Understood? Understood? Yeah. Yeah. So this is the case over there, and check it. Right. Can you calculate the time taken? Time എടുക്കാൻ പറ്റുമോ? Calculate ചെയ്യട്ടാ. Okay. Any formula you can apply. Should I understood? Now, once you've done this, we have some more numerical to do. But in between, what's the theory of the numerical? Okay. Well, last class we talk about the differentiation. So hope it is clear for you. We discuss about three kind of motion. An object is going with a uniform velocity. About a uniform velocity, there is no change in velocity means what? You have no problem. Speed is equal to what? Distance traveled by time. That is the flat equation. Easy equation. Now, next is what? Next, acceleration is equal to velocity divided by time. Right? So, if it is uniform motion, there is no acceleration at all. Easy. That's level 1. Now, level 2. In the level 2, what happens? What is level 2? Elizabeth, sorry. Isabella, what happened in level 2? So, level 2, that object is not going with a uniform velocity, but it is going with what? It is going with uniform acceleration. Uniform acceleration already equation of motions. What are the formulas? 4 formula. So when that object is going with a uniform acceleration, just apply that formula. That is formula number 1, E is equal to U plus AT. Yeah. Okay. Even one formula we that is Sn. Sn, what was the formula Sn? Sn. Displacement on the nth second. U plus half A into 2n minus 1. U plus half A into 2n minus 1. That is the displacement on the nth second. Right. Now, this is apply. Yeah, Gaurav. This can be applied when an object is going with a uniform acceleration. Acceleration change. Okay. Now, if the object is going with a non-uniform acceleration, got it? You cannot apply these formulas. Apply differentiation apply integration apply. Okay. When an object is going, let's say it started from a point 0 and let's say it is traveling for first 60 seconds travel. 0 module 60 seconds travel. Now during the time, let's say it traveled 60 seconds on it traveled, let's say 100 meter. 60 seconds on 100 meter, like 60 minutes. So, 200 seconds. 200 seconds on it traveled 100 meters. Okay. Now, if it is going with a uniform motion, uniform motion is a position time graph. Your graph will be what? Your graph will be a straight line. Then if it is a velocity time graph, your graph will be a line like this. This is an accelerated or variable acceleration motion. So if it is a variable accelerated motion, what will be the shape of the graph? So graph in the shape shape graph. Okay. So you have a variable acceleration. Graph in shape. Right? So in that scenario, you cannot apply any of that formula what we given. If you want to calculate the velocity of that object at a particular instant, let's say velocity calculate velocity calculate velocity calculate velocity calculate let's say point let's say that is 80 seconds. So 80th second velocity calculate. Okay. Now if you want to do that, calculating the velocity at the 80th second. About 80th second velocity calculate. So to do that, to calculate the velocity at the 80th second, we'll be calculating the small portion over there. Then a small portion you'll be what? Your velocity will be what? Rate of change of displacement. You'll be calculating like that. Okay? Slope it. Now, if you want acceleration over there, acceleration is equal to what? Rate of change of velocity. That we already discussed. Any tirche, they are asking you what is the distance traveled from, let's say, either 50 second. So from 50 second to let's say 150 second. So 50 second model 150 second what is the distance traveled? Right? So if you want to do that thing, distance travel differentiation sir, you are doing what? Adding all those things. You are doing the integration. Calculus second part that is integration. So regarding the integration, what you have to remember is that you know the physical quantity, that is, let's say, the position over there, that is dx. For a small second, you know the position over there, that is dx. But you want what? Total displacement. Okay. So to get the total displacement, what you have to do over there is that you know that velocity v is equal to what? Dx by dt, or the displacement dx is equal to what? Velocity v into dt. So this is actually what? 80th second displacement dx. But what you want? You want from 50 to 150 displacement. You have to integrate that dx. Okay, from 50 to 150, you have to do that, and that will be equal to what? The integral of v dt is the formula of that thing. Okay? In that scenario, position change, in that scenario, you will be doing that thing. So to do that, what you require? You require integration. This example like incorporated. So regarding the differentiation, you have certain rules are there. Integration are the rules. The first rule is the integration of a constant. So c dx. Okay. So integral of a constant that is actually equal to what? Zero differentiation. Zero. Integral of a constant is what? It is actually c into x integral of a constant. Okay. Then second rule, integral of x to the power n dx. Now integral of x to the power n dx is the formula x to the power n plus 1 divided by n plus 1. Nx raised to n minus 1 is the differentiation. But here x to the power n plus 1 divided by n plus 1. For example, integral of 5 dx that will be equal to what? That will be equal to 5x. Here integral of x raised to 3 dx that will be x raised to 3 plus 1 divided by 3 plus 1. That is x raised to 4 by 4 on our value. Okay. Similarly, if you take a function, integral of ax raised to n plus bx raised to m. So our function like incorporate this will be equal to what? A into integral of x raised to n plus b into integral of x raised to m. Now dx dx. Now integral of x raised to n x raised to n plus 1 divided by n x raised to m plus 1 divided by what? Divided by m plus 1. So you'll be doing it separately. So this is another rule related to integration. Now integral of sin x, integral of sin x dx is actually equal to minus cos x. Integral of sin x dx is minus cos x. Similarly, integral of cos x is equal to integral of cos x dx is equal to sin x ആണ് വരുന്നത്. അതുപോലെ അവിടെ ഇമ്പോർട്ടന്റ് ആയിട്ടുള്ളത് integral of 1 by x integral of 1 by x dx വരുന്നത് actually log x ആണ് കേട്ടോ, log x. അപ്പോൾ these are the important functions to be remembered regarding the integration കേട്ടോ. ഇനി അവിടെ ഇന്റഗ്രേഷനിൽ വേറൊരു സാധനം ഉള്ളത് അപ്പർ ലിമിറ്റ് ആൻഡ് ലോവർ ലിമിറ്റ് ആണ്. അപ്പോൾ ലെറ്റ്സ് സേ you know that velocity v is equal to what, dx by dt ആണ്. Now dx will be equal to what, velocity v into dt ആവും. So x will be equal to what, integral of what, velocity with respect to time ആവും. Okay, for example പറയുകയാണെങ്കിൽ let's say velocity in the value 3t square plus 2t plus 1 ആണ് വിചാരിക്കുക കേട്ടോ. അങ്ങനെയാണെങ്കിൽ displacement x will be equal to what, integral of what, 3t square plus 2t plus 1 that dt. Now this will be equal to what, this will be integral of 3t square dt plus integral of 2t dt plus integral of 1 dt കേട്ടോ. ഇതെന്താ സാധനം, this will be 3 into t square എന്താ, t raised to 1 plus 2 plus 3 1 t by 3 plus integral of this will be 2t square by 2 plus this will be t. Okay, so this is the way that will be represented. ഇനി ഇതിന് എന്ത് ചെയ്യണം, let's say you are calculating the value from 1 to 2 കേട്ടോ. അതായത് ഡിസ്പ്ലേസ്മെന്റ് കാൽക്കുലേറ്റ് ചെയ്യേണ്ടത് 1 to 2 സെക്കൻഡ് ആണ് കേട്ടോ, 1 to 2 സെക്കൻഡ്. അപ്പൊ അങ്ങനെ ആകുമ്പോ here you will be cutting it, here also you will be cutting it. Now you have to apply the limits കേട്ടോ, ലിമിറ്റ് അപ്ലൈ ചെയ്യണം. So when you apply the limit over there, you have a t cube, അതിന് അപ്പർ ലിമിറ്റ് 2 ആണ്, ലോവർ ലിമിറ്റ് 1 ആണ്. So that is actually equal to 2 raised to 3 minus 1 raised to 3 ആണ് വരിക കേട്ടോ. Plus you have a t square, അതിന്റെ അപ്പർ ലിമിറ്റ് 2 ആണ്, ലോവർ ലിമിറ്റ് 1 ആണ്. So that will be equal to what, 2 raised to 2 minus 1 raised to 2 plus you have a t. So അതിനും അപ്പർ ലിമിറ്റ് 2 ആണ്, ലോവർ ലിമിറ്റ് 1. So that will be equal to what, 2 minus 1 കേട്ടോ. So this is 8 minus 1 that is 7 plus 4 minus 1 that is 3, 2 minus 1 that is 1. So we'll be getting that as what, 11. So the answer to that particular question is 11 meter. Understood? Understood? Shudha? Understood? Any? തിരിച്ച് നമുക്ക് I'll send you. Okay now? I'll send you the picture. Right? Now, is that okay right now? Any other example? I'll show you one more example, then together I'll send you the picture. Right? Okay. So let's say they given you acceleration a is equal to what, rate of change of velocity dv by dt. Right? Or dv is equal to what, a dt. Or velocity v is equal to what, integral of what, a dt. Right? A dt. Let's say or example കാണിക്കാം. Let's say velocity v is equal to what, 2t square plus 3t raised to 4 plus t square minus 9 ആണ് വിചാരിക്കുക കേട്ടോ. This is the value. Okay. Now you want to calculate velocity. അപ്പോൾ എന്ത് ചെയ്യണം? Same thing. So velocity, sorry, this is acceleration. Right? Acceleration is this thing. So velocity v is equal to what, integral of 2t square plus 3t raised to 4 plus t square minus 9. So t square and 2t square, it is 3t square. So it will be 3t square plus 3t raised to 4 minus 9. That dt. Now integrate it there. So you have to integrate it. ഞാൻ ഇനി സ്റ്റെപ്പ് എടുക്കുന്നില്ല. So അവിടെ 3 into t raised to 2 എന്തായിരിക്കും, that will be t cube by 3 plus 3 into t raised to 4 എന്താ, t raised to 5 by 5 minus 9t എന്ന് വരും കേട്ടോ. Okay. Now ഇവിടെ 3 കട്ട് ആവും. So you'll be getting this as what, 3 by 5 t raised to 5 minus, sorry, plus t raised to 3 minus 9t എന്ന് കിട്ടും കേട്ടോ. ഇനി let's say you want to calculate the velocity from what, 0 to 1 second കേട്ടോ. ആദ്യത്തെ ഇനീഷ്യൽ 1 സെക്കൻഡ് വേണ്ടത്. അപ്പൊ എന്ത് ചെയ്താൽ മതി, അപ്ലൈ ചെയ്യാം കേട്ടോ. 0 to 1 എല്ലായിടത്തും 0 to 1 അപ്ലൈ ചെയ്താല് So here it will be what? 3 by 5 into 0 to 1 t raised to 5 1 raised to 5 minus 0 raised to 5 plus this will be 1 raised to 3 minus 0 raised to 3 minus this will be what? 9 into 1 minus 0. So this is equal to 1. So this is 3 by 5 plus 1 minus 9. You'll be getting what? Yeah, this will be 3 plus 1, 4. 4 minus 45, that is minus 41 divided by 45. So this will be what? This will be the velocity over there, that is minus 41 by 45. Understood? Now you can calculate either differentiation you see that from displacement you calculated velocity. From velocity you calculated acceleration. Okay? Integration you see the term. From acceleration you will calculate what? Velocity. And from velocity you will be calculating displacement. Either you are going backward. Point it here. You understood that idea? Got it? About integration and differentiation, when you use it multiple times, it will be okay. So board the idea cholo. I'll send you the picture right now. I said data, Sida. Isabella. I'm very hardly getting your name. Was in my tongue, Elizabeth is coming.